Hello everyone, today we'll talk about the problem magnetic force between two balls. We're given a list of possible positions. From that list we want to select m of those positions, such that the minimum distance, so the absolute value of the difference between them, is maximum. In other words, when we look at the two positions that we've selected from all the possible positions, and we look at the two closest positions to each other, their distance is as big as possible. And we want to select m of them. If you've solved the previous daily, in particular if you've watched yesterday's video, you'll notice that this problem is very similar, and indeed the solution would be the same. It will still be binary search on the answer. So how can we come up with that fact? Well, we want to maximize something, to maximize this minimum force, and of course we have this monotonicity that is necessary for binary search on the answer. That is, if we know that we can choose some positions such that their distances are equal to at least d, then of course we can also do it that they're equal to at least anything smaller than d. And also, if we know that we cannot do that with distance d, so we cannot choose m positions such that the distances between adjacent positions are all at most d, then for anything greater than d it's even less possible, right? This is an even more difficult arrangement. So that means that we can binary search on the exact value where it becomes impossible, or the last value that it's still possible to select those m positions. And of course, to verify for given distance if it's possible to get at least that distance, then it's the same as in the previous problem. We can just do it greedily. Take the first position. We are assuming that positions are sorted. We have to remember to do that because the problem doesn't give us those positions in sorted order. We take the leftmost position, then the leftmost position that's at least a distance away from the previous that we've taken. And of course, if we get at least m, then it's possible. If we cannot select at least m, then it's not possible. If something is still unclear, then we'll look at the code, and of course feel free to watch yesterday's video about the previous daily. So again, we need a function. This is the function that will be monotonous with respect to this distance, that we'll use to binary search. And this function is just one that verifies if it's possible to get at least given distance. And again, we take the first position and then we keep taking positions that are at least dist apart. So if they're not at least dist to the right, we cannot take it, otherwise we just take it and remember that this is the last position we've taken. And of course, if we've taken at least m, then it's okay, otherwise it's bad. And now here's the binary search that I write with jumps to the right. So we start with some lower bound. This is of course always possible. It's always possible to have this maximum distance be equal to at least 0. And we take some maximum that we cannot make bigger. For instance, the maximum of the array plus 1 is definitely greater than the answer. We take the jump equal to half of that max answer, and again, we will be considering jumps that are, each next jump is half as long as the previous one. We try to jump forward by that amount, and if it's still okay, then this is our new answer. And after that, especially considering that the last jump will be of size 1, our answer will definitely be the last position where it's still okay. So we just return the answer.